we learn about the octet rule, that is according to which during the formation of a molecule, every element try to achieve 8 electron in the outermost orbit. But at the same time, we have the exception for this octet rule also, or we have some limitations also for with respect to the octet rule. Now the limitations, we come to know there are the certain molecules in which we observe that the central atom does not have 8 electron in the outermost orbit. Means either it have 8 electron, more than 8 electron in the outermost shell, or the less than 8 electron in the outermost shell. And if I am following the octet rule, then octet rule says that a molecule will be stable only if it is having 8 electron in the outermost shell. So if there is a more than 8 or less than 8 electron in the outermost shell, then stability will not be there. But we come to know that those molecules which are having less than or more than 8 electrons are also stable. Now let's see certain example. As I said, there is either possibility for having less than 8 electron or more than 8 electron. So the example, the first part is, or the first limitation is incomplete octet. Incomplete octet, these are the molecules in which I can say the central atom is having less than 8 electron in the valence shell. First example for this is the formation of BeCl2 molecules. Beryllium chloride. We know that beryllium chloride is existing in a nature, and if it is existing in a nature, that means the beryllium chloride is stable. But when we think about the octet rule on this beryllium chloride, then beryllium chloride molecules should not exist according to octet rule. Let's see why. So beryllium chloride, the central atom is beryllium and the surrounding element is the chlorine. Beryllium atomic number is 4. So its electronic configuration is 2, 2. That means I can say beryllium have 2 electron in the outermost orbit. Chlorine atomic number is 17, so its configuration is 2, 8, 7. So chlorine have 7 electron in the outermost orbit. Okay. Now the formation of beryllium chloride. How beryllium chloride is formed? So beryllium is at the center, have 2 electrons in the outermost orbit, and there is a 2 chlorine atoms. The chlorine, beryllium, since it is having a 2 electron in the outermost orbit, so at least it will share 1 electron with this and 1 electron with this. The same thing will happen with the chlorine also. The chlorine having 7 electron in the outermost orbit, 2, 2, 4, 2, 6, and 7th electron will be shared. Same thing here, 2, 2, 4, 2, 6, and the 7th electron is shared. So ultimately I can say that here the beryllium chloride has been formed. In case of this beryllium chloride, you can see that chlorine is having 8 electron. This chlorine is also having 8 electron. What about this beryllium? This beryllium circle is containing only 4 electron. That means in a beryllium chloride, the central atom beryllium is having only 4 electron in the valence shell. That means it have less than 8 electron. And according to octet rule, a molecule which is forming, during the formation of a molecule, every atom try to get the 8 electron in the outermost orbit. That means a molecule will form only if each element is having 8 electron in the outermost orbit according to according to octet rule. But here the beryllium doesn't have 8 electron, but still it form a molecule. So why it is forming a molecule is not explained by the octet rule, and hence it becomes a limitation. According to octet rule, this molecule should be unstable, but this molecule is stable and it is existing in nature, and its stability was not explained by the octet rule. Beryllium chloride, it is a linear structure or linear molecule, that means having a linear structure. This angle is 180 degree. Then second example for this, incomplete octet is BF3 molecule, boron trifluoride. Again here the boron is a central atom whose atomic number is 5, its electronic configuration is 2, 3, so I can say that boron with the 3 electron in the outermost orbit. Fluorine, whose atomic number is 9, so its electronic configuration is 2, 7, and the fluorine having 7 electron in the outermost orbit. Boron trifluoride, the molecule will form boron at the center and having 3 electron in the outermost orbit. and it's combining with the 3 fluorine. So there will be a sharing with 3 fluorine. These are the 3 fluorine. Now in case of this, since boron is combining with the 3 fluorine, that means at least boron will form single bond with 3. So at least it will uses its 1 electron. So all 3 electron is shared. Then fluorine, each fluorine is having 7 electrons. Out of this, 1 is shared. 7 electron again, out of which 1 is shared. 7 electron again, out of which 1 is shared. So I can say that here in this case, this fluorine is having 8 electron, this fluorine is having 8 electron, and this fluorine is also having 8 electrons. So what about the boron? Boron present at the center is having only 6 electron in the outermost orbit. Again, I can say this becomes a limitation of the BF octet rule, because in this case also I can say that boron which is present at the center is having less than 8 electron, that is, it is having an incomplete octet. And if let's say the structure of BF3, this is the structure BF, F and F. The geometry is trigonal planar. We will learn about the geometry. We are going to learn about these all geometry in the next remaining part of the chapter. Then the second limitation. Expanded octet. Expanded octet. Expanded octet, it's as the name says here, the central atom in a molecule, the central atom is having more than 8 electron. Let's see the example for expanded octet. Example number 1, formation of PCl5 molecule, phosphorus pentachloride. Here the phosphorus whose atomic number is 15 and its electronic configuration I can say it's a 2, 8, 5. That means phosphorus having 5 electron in the outermost orbit. Chlorine, atomic number is 17. Each chlorine is having a configuration 2, 8, 7. That means each chlorine is having 7 electron in the outermost orbit. Now they will form a bond. So phosphorus will be at the center, surrounded by the 5 chlorine atoms. 1 chlorine will be here, the second chlorine, third chlorine, fourth chlorine, and ultimately 5th chlorine. Each chlorine is having 7 electrons, so 1 will be shared. This chlorine will also share 1 electron, same thing here. So each chlorine will have now 3 lone pair electron and 1 is the electron pair which is shared. Now what about the phosphorus? The phosphorus is having 5 electron in the outermost orbit, and since the phosphorus is sharing its electron with the chlorine, so at least 1 electron will be shared. So 1 with this, 1 with this, 1 with this chlorine here and here. So all 5 electron of the phosphorus has been shared. Now in this case I can count here that for chlorine 2, 2, 2, 6 plus 2, 8 electron. Each chlorine is having 8 electron. And what about the phosphorus? Then I can say that phosphorus is having total 10 electrons. That means more than 8 electrons. So here the phosphorus, why it is forming a 5 bond with the chlorine when it is having to get this total 10 electron in the outermost orbit. So in PCl5, why the phosphorus is having 10 electron in the outermost orbit and still stable is not explained by the octet rule, and hence it becomes one of the limitation of the octet rule. The second limitation here we can say, the formation of SF6 molecule. For SF6 here the sulfur atom atomic number is 16, its electronic configuration is 2, 8, 6. That means sulfur with a 6 electron in the outermost orbit. Similarly for fluorine I can say whose atomic number is 9, that is 2, 7. 7 electron in the outermost orbit. So sulfur with a 6 electron in the outermost orbit and forming a 6 bond with the fluorine. Here for the PCl5 I can say the structure is the phosphorus at the center, Cl, Cl, and this is the third chlorine. These three chlorines are in a same plane, while there is a two more chlorine, that is these two chlorine, which are perpendicular to the plane. Again, why this structure is formed, we will learn. Okay, so SF6 molecule, first fluorine here, second fluorine, third, and sixth fluorine. Each fluorine is having 7 electron and it shared one, out of which shared 1 electron with the sulfur. Sulfur atom having 6 electron and it shared 1 electron with each fluorine. So now the sulfur SF6 molecule is having total 12 electron. That is, a central atom is a sulfur which is having total 12 electron in the outermost orbit. So why sulfur means in SF6 molecule sulfur is having a 12 electron, that is a central atom. Why it is happening, this is again not explained by the octet rule, so become limitation. SF6 structure is octahedral structure, we call it. These 4 fluorine and 1 sulfur is in a same plane, while there is a 2 sulfur atom which is perpendicular to the plane. That is called as square bipyramidal structure, or also known as octahedral structure. This is the second and third limitation. Odd electron molecules. Odd electron molecules, there are the certain molecules which are having the odd number of electron. Total number of electron in that particular molecule is odd. So how this odd electron molecules are forming is again not explained by the octet rule. At least these are the molecules I can say, or whatever the molecules we study in this part, those all molecules are having even number of electron. For example, here you can count each chlorine 6, this chlorine 6, sorry 8, that is total 16 electrons. So similarly here 24 electron if you will count. Here total electron if you will count, then it is going to be 40. Here the total electron if you will count, it is going to be here in this case the total electrons will be 48. But there are, means in all the cases, or whatever the examples we did in the ionic bond and the covalent bond, in all those cases the molecules were having at least even number of electrons. But there are the certain molecules which contain odd number of electrons. Let's see the example for such molecules. Here the example is the first one, NO molecules. The bond is formed between the nitrogen and oxygen. Each oxygen is having a 6 electron. Now let's see how it is formed. Nitrogen and oxygen. Oxygen was having a 6 electron in the outermost orbit and the nitrogen 5 electron in the outermost orbit. Now oxygen required 2 more electrons for completing an octet, so it shared 2 electrons. So similarly this nitrogen will also share 2 electrons, so these 2 electrons, and oxygen share these 2 electrons. So now the octet, oxygen, total electron is 2, 4, 6 and 8. That is octet of oxygen is completed. What about nitrogen? 2, 3, 5, 7. Here the nitrogen wants to share 1 more electron because its octet is not completed. But in this case the oxygen is not ready to share its electron because oxygen octet is complete. So in this case, how this molecule is forming, where the nitrogen is also not having its complete octet. And here the total number of electron is odd number electron. How odd number electron? If we can count here 2, 4, 4, 4, 8. Total electron you have to count 1, 2, 3, 4, 5, 6, 7, 8. This 4 electron is again present in nitrogen, but you have to count it once only. 8 plus 3, that is 11. So total electron is 11, 3 with the nitrogen, 4 is shared and 4 is with this. So 11 electrons. So structure is going to be our bonding between nitrogen and oxygen, double bond. Oxygen is having 2 more lone pair of electron. Nitrogen is having here 2 electron, that is a lone pair, and this one single electron. So this is NO molecule. Similarly, the same thing happened in the case of NO2 molecule also, where the nitrogen is at the center, oxygen and this oxygen. Here this oxygen is forming the bond between this nitrogen and oxygen is a covalent bond, that is both nitrogen and oxygen is sharing electron, while this bond is a coordinate bond. Now in this case nitrogen coordinate bond, that is a nitrogen has given its 1 electron here, and oxygen have used no electron for the bond formation, and this oxygen is having 4 electron. Now in this case, if I'm measuring the total number of electron, then 2, 4, 6, each bond is having 2 electrons, so 6, 8, 10, 12, 14, 16 and plus 1, that is 17 electrons. So this is having total 11 electron and this one is having total 17 electron, that is odd number electron molecule. So how odd number electrons molecules are forming is again not explained by the octet rule. The limitation number 4, the fourth limitation was that the octet rule only talks about the bond formation. It doesn't tell us anything about the shapes of a molecule. That means once a molecule is formed, for example, here I had written the shape of BF3 trigonal planar, this is trigonal bipyramidal, this is octahedral, this is linear. This structure was later discovered or by using some other theory. This structure was not explained by the octet rule. The next, the octet rule also tells us about the stability in terms of energy. It says that stability in terms of 8 electron in the outermost orbit. I said in the beginning only that every atom, why an atom form a bond, then it only satisfies to get the stable electronic configuration of 8 electron and to get stability in terms of energy. So octet rule doesn't talks about the second point, that is the stability in terms of energy. So these are the limitations of the octet rule.